Hello everyone, and thank you for joining me in this video short where we're going to talk about basic structures. Specifically, we're going to look at some of the underpinnings, the nuts and bolts, of a computing system related to computer memory and organization. And we're going to discuss, why we care about that. Specifically, when designing a data structure or storing data in a computing system, we need to make a decision. Do we want to store this data contiguously in memory or discontiguously in memory? There's a pro-con trade-off based on that decision. Of course, as data scientists, we want to leverage this understanding of memory management so that we can write better and more efficient code. So when we think of a simple linear structure where we'll store data like a list, something like this, there's a decision we can make when it comes to building a data structure. Do we want to store the data contiguously in memory or discontiguously in memory? When we store data contiguously in memory, we refer to that base structure as an array. When we store data discontiguously in memory, we refer to that structure as a chain or a linked list. Now, essentially, all data structures are based on one of these two underlying basic structures. Right? For example, a Python list is an array, right? And a hash table or a dict is an array with a hash function associated with it. Right? But some tree structures, for example, are built as chains. We'll talk more about those upcoming. So what is the pro-con trade-off? Well, when a computing system makes a reservation in memory so that data can be stored, that reservation is fixed in size. And so if we are going to reserve memory for an array, then we need to identify a chunk of memory that's contiguous of a particular size, and we can make that reservation. Once that reservation is made, the size of that reservation cannot change, meaning the size of the array, once it's been initialized or once it's been created, is fixed. So if you fill up your array and you need to add more items, right, you can't really do it in that array without creating a new array. And so that is the con. The pro of using an array is that the data is stored contiguously in memory. Why is this a pro? Well, since we know that each item is contiguous in memory, and assuming we know where the array begins in memory, we can jump to the second item in the list by doing some simple memory math or pointer arithmetic. That is, just simply start at the base memory address and then add 2 spaces, or add 5 spaces, or add I spaces, and we can perform what's called direct indexing. That is, we can retrieve the ith item in a constant number of steps, rather than having to traverse the entire list or the array. Right? So it's very efficient in that sense. The con, as we noted, is that the size cannot change. If the array fills up, right, then we are out of luck. Right? However, there are ways around that. Chaining, however, is the opposite. Rather than storing data contiguously, we store the data discontiguously in memory. The pro here is that the size can change because for each item that we want to store, we create a new reservation just for that item. So the first item, we make a reservation and store it. The second item, we make a reservation and store it. How does the computer know what the second item is or the third item is in the list? Well, we know where the first item is, right? And whenever we add an item to the list, we need to implement a chain or a link so that the computing system knows, all right, well, I'm here at the first item. Where's the second item? Oh, I need to follow that chain. And then it takes you to the new place in memory where that second item is. And then there's a chain to the third item, and then a chain to the fourth item. So the pro here is simply that the list size can grow dynamically because multiple reservations are made. The con, however, is if you want to go to the fourth item in the list, if you want to go to the 10th item in the list, if you want to jump to the ith item in the list, you actually have to follow that chain to get there, meaning you have to start at the beginning of the list and then perform I traversals, essentially, or I jumps to get to the ith item. There is no direct indexing. And so going to the ith item or the nth item in a list is going to take on the order of n computational steps. And so direct indexing is very slow when using chaining. So that is a con, and it's a pretty steep con. All right, well, thank you for joining me in this video short. I encourage you to review some of the examples in this PowerPoint slide deck, where you can see these pros and cons and some final time complexity analyses. Thank you for joining me.